Thank you.
Oh, not me.
So we're going to be talking about the order you write polynomials and then adding and subtracting polynomials. That's where we are headed today. Okay, so the first thing we're going to talk about is how to write them, right? So that's the order. So writing polynomials in standard form. I know this was in the video. You must order the terms from greatest to least by degree. So if I gave you this example, six x to the fourth plus 7x to the eighth minus 9x to the third, I need to rearrange it. And there was something very specific in the video that the guy explained, how we're not really adding or subtracting. What do that addition and subtraction symbols actually mean in this situation? Eden? Positive or negative, right? So he actually rewrote the polynomials as being addition of either positive or negative values, which I think is a really good visual. So if I was going to rearrange this in order from greatest to least by degree, what would the correct order be? Hayden?
7x to the 8th, 6x to the 4th, and then negative 9x to the 3rd.
Right, so I'd have 7x to the 8th plus 6x to the 4th, because we know this is positive because it's not negative. And then I would subtract 9x to the 3rd. That would be the correct way to put that in order. And the reason this is important is because the next thing we're going to do is adding and subtracting. And they're not all going to be in nice, neat order for you. So you're going to have to add and subtract and then maybe rearrange based on the degrees that they have. Okay. So in our second example, 5x minus 4x to the third plus 2x squared. So how would I rearrange this? I'm not changing any values, I'm just putting it in proper standard form. What would that look like? Eden?
Negative 4x to the 5 plus 2x squared 5x.
Yep. What degree is hiding here with the x? A 1. And how did he explain that you just have a value that doesn't have a variable? Do you guys remember how he explained that? Eden?
Because it's the variable just equals 1, so it doesn't really change the time.
Right, it's like saying x to the 0 power, which we all know is 1, so you don't need to have it there, right? So even though it looks like it's strange, like if we had like plus 10 out here, that would be like 10 times x to the 0 power, which is 10 times 1, which is just 10, right? Does that sound familiar?
Yeah.
The video? Okay. Questions about this before we move on to adding and subtracting? Okay, so I'm going to go on to a totally different page now and just do adding and subtracting on that page. So we've got, we could say a trinomial plus a trinomial, or you could say a polynomial plus a polynomial, however you want to say it, same thing. Got lots of different degrees here, right? So 2x to the third minus 5x squared plus x plus 2x to the third plus x squared minus 1. What do you guys remember about like terms back when you first learned about equations? What do you have to have in order for something to be considered a like term? Same what, Avery?
Same base.
Same variable and maybe same, sorry? Exponent. You can only combine them if they have the same variable and same exponent, right? Otherwise, you cannot, they can't be combined. So I can combine 2x's to the third and 2x's to the third because x to the third is the same. Does that make sense? I can combine those coefficients, right? I cannot combine 5x squared with those because whatever x equals, having something to the third power is not the same as having it to the second power. You guys following? Yes, Hayden.
Could you add the x squared plus the negative 5x?
Sure can, because they have the same variable and same exponent, right? I cannot combine this x and this negative 1 because this is maybe worth 12 and this is not, right? So we have to make sure that they have the exact same exponent and variable in order to combine them, okay? So what this looks like, I'm going to use red, blue, green, and yellow. You guys can use whatever colors you want as long as they're consistent on your paper. You match them up correctly. Okay, so I'm going to color code. I can combine, like we just said, 2x to the third and 2x to the third. And this is adding. So if I were to distribute a positive 1 to each of these values, does it change their value? This is still going to be positive 2x to the third, this is still going to be positive x squared, and this is still going to be a negative 1, right? So this right here tells me none of these values change either to positives or negatives. Keep that in mind for when we do subtraction. All right, then we've got negative 5x squared and positive x squared. Those can be combined. And then I've got an x who's going to be by himself, and I've got a negative 1 that's going to be by himself. So when I combine these, how many x's to the third power do I have? 4. How many x's squared do I have? Negative 4. How many x's? Just the 1. And then I have this negative 1 hanging out by himself. So I combined these to get this value. I combined my yellows to get this value. And then the green and blue just came along for the ride. Nothing changed for them. And this is my answer. I feel like I went too fast over this positive 1 thing. Does everybody understand how, by distributing the positive 1, none of these values changed? Okay. All right, let's do another one. All right, so I've got 4n squared. I'll keep that, let's see here, yellow, because I did x squared up here. Do I have anything that can combine with 4n squared?
Yes. Yeah.
What is it?
Negative 7.
Negative 7n squared. How about 5? Does anything combine with just that plain old 5?
No.
Nope. So I'm just going to make that blue again. How about 5n to the third? Does anything combine with that?
No.
Nope. And then we just have 6n hanging out by itself too. Positive 6n. So now when I write my answer, I want to put it in the proper form by decreasing degree values. So what's going to be my first term for my answer?
5.
Yep. What will be my next value?
Negative 3 to the power of
Negative 3n squared. How did you get that?
because negative 7 n squared plus 4 n squared equal negative 3 squared.
Yep. So I've got my red, got my yellow, got my green, and I've got my blue.
So would it matter if you put the 6 and 5 first?
It does, because this is like having a 1, and this would be like having n to the 0 power.
Okay.
Yep, good question. Okay, adding's the easy part, or easier part. They're both pretty easy, but adding's the easiest. Because the symbol in front didn't change, right? Hayden, did you get your pencil?
Yeah.
Okay, good. Do you have big plans for today?
My mom's taking me to my favorite restaurant,
What would that be?
the local.
Oh,
That's 10 years.
very nice.
Yeah.
Okay, all right, fancy. I like it. Okay, let's jump into subtracting polynomials now. I just had to order a birthday cake for my son. His birthday's on Tuesday. And I don't know why, because we've never seen the movie. We've never watched any cartoons, but apparently he likes Aquaman. So he wants an Aquaman cake. So I went to the Dairy Queen in Westfield. You guys know about DQ Diana?
Yeah. Yeah.
She's going to make an Aquaman cake for him.
Nice.
But Aquaman, I don't know. You guys, who doesn't know about DQ Diana? She's fantastic. You can give her like any picture and she can draw it on a Dairy Queen ice cream cake. Like she is like has a special talent for like that gel icing. And I don't know if you guys have ever seen her. It's phenomenal. People post about it all the time on Facebook. I know you guys don't go to Facebook, but she's very popular. In fact, he said it's a good thing I called because she already has 30 other orders to do between now and Tuesday. DQ Diana. She made it in the Westfield Current, which is very popular. Do you guys know what the Current is? It's like a little local newspaper. They have one for Westfield and Noblesville and Carmel, and I think Fishers has one too. Local celebrities. Okay, let's go into our examples. So it's going to start out looking the same. So we've got a couple polynomials that we're subtracting. Looks innocent enough. However, we have this right here. We now have to distribute a -1 to all of these terms, which will definitely change their value, right? So my suggestion is to just rewrite this as an addition problem after distributing the -1. So put your pencils down for a second so you don't miss this crucial step. Kike, pay attention. You're going to be the one to ask.
What?
You're always the one to ask.
That's what?
Everything. Okay, so my first polynomial doesn't change. I'm going to change this to addition. What is -1 times 3x squared? -3x squared. What's -1 times -1x? Positive x. -1 times -8. And now I have an addition problem. Yes, Kike?
Why did you add an addition sign?
Oh my God.
Because after distributing this -1, I've changed all these values, and now I can just add these as they are with their new symbols. Yep. That's how you do it. Okay, so I'm going to do yellow for my x squared values because that's been consistent. I'm going to use green for my single x values. Oh, I've got 2 blues this time. What's my answer going to be? He's feeling super confident. Like this is easy peasy. I can do this in my sleep. Eden.
X squared minus 2x plus 13.
Perfect. X squared minus 2x plus 13. How many of you had that on your paper? Nice job. Okay, last one. And then you're going to do some practice. can collaborate while you're practicing. Ooh, a lot happening here. This is a 2. It's a really ugly 2, but it's a 2.
Wait, what about, is it a plus or a minus in the second?
Oh, that's a plus. You just can't see the, there you go. Thank you for asking. Is that better? Okay, perfect. Okay, what should I do first? Mackenzie? I heard you say it.
Distribute the -1.
Awesome, thank you. I'm going to distribute this -1 so that I can turn this into an addition problem. So I'm going to have 4m squared plus 2n minus 3n squared. That doesn't change. Plus -5n minus 6n squared minus 3m squared. That did some damage. All right, what do you notice about these two polynomials that we haven't had yet? Callie?
There's 2 different variables.
Yeah, we've got m's and n's. You can still only combine them if they have the same variable and exponent. So I can't combine 4m squared with 6n squared. It's not a thing. Can't do it. Right? So let's see here. I can combine 4m squared with -3m squared. I can combine 2n with -5n. And then we'll use red for this one. -3n squared and -6n squared. Now you're probably wondering, like, what order they go in if you have more than 2 variables, right? Because it was easy before. We just had the x's and we just went greatest to least for the degrees. So for these, we're going to go alphabetical variables, greatest to least. Does that make sense? So I'm going to do the m's first because they come before n. So I'm going to have just m squared, because 4 minus 3. I'm going to have -9n squared, and then -3n. Who's excited? Woo! Calm down, Logan. Just polynomials. We have a lot to learn before you have another test. Okay, I'm going to pass this out and explain how this practice works. So when you take a look at this, kind of complicated. All right. So we have 1, 2, 3, 4 problems along the top. Does everybody see that? These two polynomials are being subtracted, added, right? Maybe you want to distribute and write the new one down here, whatever works best for you to keep track for when you're doing subtraction. Then you get these answers, and you have 2 problems. So here's the catch. If you make a mistake here, where else are you going to make a mistake? Everywhere. So be careful. Don't be in a rush. It's not a race. I'm not going to high-five you or give you a trophy if you finish first. Take your time. Work the problems out. Pay very close attention to the variables and the degrees. Right? And then if you look at the bottom, it works its way up. So you have 1, 2, 3, 4, right? It's like a bracket, which is fitting for March, isn't it, Elizabeth? Yeah? And then your final answer. This is not homework. We're just getting started on it right now, so take your time. Questions? Yes, you can go move, Jackson. I know you want to go sit by your best friend.